If you haven't done so yet, please pause the video and try to solve the question on your own before listening on. What we need to do first is look at the equation for magnetic force on a charged particle. So in that equation, we have the product of the amount of charge on the particle, the speed, the magnetic field strength, and then the angle between the magnetic field and the velocity of the charged particle. Now we'll notice that all of the values in the equation were given directly to us. So for example, the speed v was given to us in a standard unit, the magnetic field also given to us in a standard unit of Tesla, the angle between the velocity and the magnetic field was given, and then also the charge is given, but it's sort of implied. They said that we are dealing with sodium ions, and then they put a little plus sign on it. Well, that plus sign indicates that the charge is positive 1.6 times 10 to the negative 19th coulombs. So with all those known values, we'll simply plug in and calculate the force acting on a sodium ion. And after plugging in the known values, we get a magnetic force of approximately 2.69 times 10 to the negative 20 newtons. Now that's the force acting on just a single sodium ion, but we don't have a single sodium ion. We have several more than that. So our next step is to figure out how many sodium ions there are. So the number of ions would equal the following equation. You might want to pause the video and just study it for a moment. But basically we're taking the volume density of ions and multiplying it by the volume. If we set it up in that way, we can see that when we multiply, these centimeters cubed will cancel, leaving us with just the number of ions. Now the number of ions per centimeter cubed was given to us directly in the question. And then the number of centimeters cubed, or the volume, if you will, was also given to us in the question. So we're just going to multiply those two values, and that will tell us the total number of ions. And so when we multiply those two numbers, we get 3 times 10 to the 22 ions. Now recall that we determined the force acting on just one ion, so we can almost say this is the force per one ion. So what we'll do is multiply that force per one ion times the number of ions, and that's going to give us the total force acting on the arm. And so we can see when we multiply these two values, the unit of ions is going to cancel, leaving us with just newtons, which is exactly what we want. And the value of this force turns out to be approximately 807 newtons. So this would be the total force acting on the arm. Thanks for taking the time to watch that video. If you liked it, please click the thumbs up icon and share it with your friends as well. Don't forget to subscribe to the channel so you can stay tuned for additional videos. And you can send in your own question to this email address on the screen, and I'll do my best to post an answer to it on YouTube.